So good morning, everyone. Happy to see all of you and this high attendance of this workshop about modeling best practices. And I'm Giorgos Athineu. I'm a data engineer at Project A. This is the second leg of the data modeling best practices workshop done by our dear Dr. Martin Lodge, who is currently the Chief Data Officer of Project A and having quite some experience around these topics through the years. So yesterday we had a very interesting covering of modeling best practices from a more conceptual point of view. Today we'll see more on the technical perspective, covering practices around building pipelines and more. And closing this intro, I would like to also mention and encourage you to keep it as interactive as possible and to ask questions along the talk of Martin. And of course, we're going to leave some time at the end for more. So Martin, please go ahead.
Yeah, thanks, Yorgos. As Yorgos said, today it's going to be a bit more technical, or sometimes maybe also very technical, right? So I want to give you some best practices about how we build data warehouses. They will be seemingly in some rather random order because the points I will be making don't really have a natural order to explain the story well. So please bear with me. And as Yorgos said, please ask questions anytime. Right, so yesterday we talked solely about this single analytical truth. Right, so we said, okay, you need to ingest all the data of your company somewhere and then build something that you can use then across your company in reporting, machine learning, marketing automation, and so today we focus only on building this single source of truth as, in fact, a set of tables in an actual database, right? So we will talk about how to step-by-step build these tables, fill them with data that then eventually can be used for all these use cases. For me, the challenges in doing so might be a bit surprising. For me, the biggest one is consistency and correctness, right? So to ensure that the data that you see there is consistent across different domains, that the data that comes in also ends up somewhere in the reporting fact tables, and also that the data is correct, so that people who look at it today and look at it tomorrow are not surprised by the things that they see. Right, so both chipping in on the trust that users have in your data infrastructure. Almost as difficult, or maybe also almost as important, is changeability. Right, so once you have a dimensional model and you have a data warehouse, and with increasing business complexity and with increasing team size, it can become harder and harder to change things, right? So in the beginning, you iterate very quickly, and the challenge is to remain that agility, or to keep that agility also in later stages of the data warehouse, right? So to still make it easy to get changes in production. Then there is the whole point of dealing with complexity, right? So complexity in the data itself, in the business processes, but also then in the pipelines that you will build. And most of the tips that I'm going to give today are around this dealing with complexity. And there is a challenge also, right? So as soon as you build something, then there are questions about transparency, so that people want to know how is revenue actually computed, but we will not cover any of that today. Right, so we talk about building these tables, and this can be very difficult at times. So here you see two data engineers fixing a pipeline at 8 a.m. in the morning. And right, as I also said yesterday, it's very easy to build a lot of technical depth and technical complexity that will make it very, very well. That first of all will make your life stressful, right? So when you have to fix broken pipelines to put out fires, or also that will make it then difficult if you want to find a bug or an inconsistency, or if you want to change things. Right, so the whole presentation today is about how being a data engineer or an analytics engineer can be less stressful if you follow certain best practices, right? So as I also said yesterday, this whole dimensional modeling only has the benefits that we discussed if it's done so-called well. Yeah, right. So today it's mainly a random collection of best practices for coping or dealing with complexity. We will not talk at all, or maybe only briefly, about actual technologies like database and orchestration tools. So all the patterns that I'm going to show apply as well equally well to BigQuery, Snowflake, Postgres, and other databases. It also well can be done in things like DBT, Mara, and others. Airflow. Yeah. So, as I said, please interrupt me anytime. In general, and well, those of you who work with me doing previous presentations. Right, so the overarching theme of everything is to make changing and testing things easy. So you have something, and now you want to add one more attribute or one more metric, and to doing that should be easy, and it should happen in a controlled way. And how you do that? You apply standard software engineering best practices, right? So the normal best practices that people use who build backends or who build websites or any other piece of technology, for me also apply to data warehousing and data engineering. And what does that mean? Right? Well, specifically for data warehousing, it means data pipelines as code, right? So that you don't do things manually, right? So you don't manually create views, you don't manually put data somewhere, but you basically have a bunch of SQL files, some Python scripts and shell scripts, and you put all of those in some Git repository, right? And then you run these SQL files, these Python functions or files and shell scripts, and in the end, both the structure of the tables of your dimensional model, but also the content of these tables are the result of running code. So this was, I would say, a bit, was a bit controversial maybe 5 years ago, right, when people would rather use so-called click ETL tools. Nowadays, with things like Airflow and especially DBT, this has become a total mainstream opinion or approach. Right. So if you use code, like so text files, then these are easy to read. So everybody knows how to read SQL files or how to read Python files, and they're also easy to debug. Right. So if there's a problem, then you check what kind of data went into a SQL script and run it again and analyze it, compared to looking into or clicking on some nodes in a graph and trying to figure out what's happening in those. And also, if you use code, so text files, then you can have normal software engineering workflows, right? So that you develop locally or at least in your own development environment, then test on some testing system your changes, right? And then once that works, deploy that to production, all powered by Git, so that the code that you have is maintained in a Git repository, and once it works, merged to master and deployed. Right, so I would say this is nowadays super mainstream, and can be done with things like DBT, with Mara, with anything that has this pipelines as code. Then on top of that, there is also the really nice development of functional data engineering. This is an article I recommend reading. It's already 3 years old, from Maxime Véchaumont. I don't know exactly how to pronounce his name. He is the original author of Airflow. Right, and so I think he coined that term. What is it about? It's about reproducibility. That means that if you run a transformation on the same input of data, then it will always produce the same results, right? So that means if you want to test something and you run something, then maybe you make a change to that transformation and then you run it again. So you will always get the same results if you run it on the same inputs. This also is true for whole pipelines. So if you run a pipeline that processes marketing sessions or that processes customer service requests, running the same pipeline on the same inputs always produces the same results, which is super nice for, well, if you want to trace errors, right? So it would be bad if you want to trace a bug and would always get different results depending on whatever. But it also makes it nice. So if the thing worked on a testing system on the same data, it will also produce the same results in production on the same data. The second aspect of this is item potency. That means not having side effects, and we will come to that later. But right, so essentially, if you run a pipeline, it should not kind of write stuff else somewhere else, right? So the running a task or a pipeline or any kind of unit of work should only modify its own data, but never kind of do changes elsewhere in your data infrastructure, because then it will be very hard to reason about the state of your data if it depends on the specific order in which things ran. Maxime also has strong opinions that are strongly baked into Airflow about immutability, so that you basically, once you computed a time partition of some batch processing, that you never compute it again. That makes, for me, Airflow a bit hard to use, but we will not cover it. Right. So basically, I think what you have to take home from here is that running a pipeline on the same inputs will always produce the same results, and you should never have side effects. Okay, so this is quite abstract. Let's get into really what that means. Right? So what does it mean to run SQL files, Python and shell scripts? And let me start with what not to do, because often, especially in early stages, so people see the need, okay, they need to do something, and then they write Python scripts where you load some data into a pandas data frame, then do some transformation in the frame, but because it's very easy to do stuff in pandas, and people who kind of get into the field of data science, they are taught pandas. But also, right, so people then write Spark drops or write things on Presto, where they also, right, so where they have data sitting somewhere, and then they process the data in the GVM. And this can be very expensive. And I encourage every one of you to read this article by a guy called Haki Banita. This post here is in general about, so specifically for people who come from this pandas data frame world, so and how and kind of shows them patterns of how to do analytical use cases in SQL. So I really recommend it. But they also have this analysis of the overhead of doing things in Python and Panda and so on. So he did this really simple analysis where there was a 1 million users table with some activated flag, and he was just counting the different rows for this activated column. And so he kind of, his recommendation is to not use pandas for analysis. Right, so the original, so the main thing, because the main thing is that the original table in the database was only 65 megabyte, right? But the pandas data frame itself was already 300 megabytes. So there is a huge memory and time overhead of taking the data out of a database and then doing something in memory. So here are the comparisons. Right, so the first row is that I took one. So there was the run where it took an average 1 second, where he basically read the whole table and then grouped them and did the count. In the second one, he only pulled the queries that he actually needed, right? And this made already a quite significant reduction in memory, but also runtime. Then what he actually then did is to do the computation that we see above already in the database. And that, well, has had a drastic effect on the memory usage and also on the runtime, just because databases are usually faster in doing stuff than, pandas or any kind of other computing framework are. And well, his point then is also, if you don't use pandas at all and just use the native database client to retrieve a result, then, well, you have a much lower memory footprint, because just loading pandas already requires 35 megabyte of memory, and it's then only a tenth of the original time. Yeah, so this is the primer for what to actually do, right? So my recommendation is to use SQL as a data processing to leave data as much as possible in the database, and basically create a set of SQL statements, run them one after the other, maybe and then also somehow in parallel if possible, and then each of these SQL scripts creates a table, and that table is then the input to another transformation step. So how can that look like? Right. So here we want to create a region table. So this here is now Postgres, but you could do very much same thing in BigQuery or Snowflake. So you create this table, then has some types and maybe also some constraints already. And then you do a computation, right? So here you get distinct countries and region from a marketing session table. And then, well, you do something like creating unique IDs and making region names unique and well, computing country IDs. And then, well, inserting that into this region table. Then you might also maybe want to add something like an unknown region. And once you are done with that, you add indexes and maybe also analyze the table. This would, right, so this is now declarative SQL, as you would do in Mara or Dataform. If you use DBT, then you would basically create a model that doesn't have this insert statement, but all the rest is the same. The unknown values you would insert with a union to the previous query. And so you would basically write a select query, reference the data source, and then in some YAML file specify that columns should be not null, that there are primary keys, and so on. All right, so but this is already the whole idea of SQL-based transformations. Each processing step is a query that creates a table, usually a materialized table for, unless you have some performance issues. Materialized tables make the whole thing, I would say, more robust and easier to reason about and to debug. Is there questions about this? Yeah.
Yes. I don't. So the idea is to always create intermediate tables as results, right? Before
Yes.
actually inserting into our main table, right?
Well, if you mean main table, the ones that you are then consuming and reporting and other use cases, then yes. Right. So there's a long chain of different steps, and we will also later come to how to organize them a bit into layers. But yes, so you create one table after the other, and in the end you have your final table that you use.
Okay. But now I am processing, so these intermediate results are coming from other tables, right?
Yes.
I mean,
so this here one, so this here one reads from a session table. That's in the CTE over there.
I cannot see where you are pointing. Are you pointing somewhere?
I can't point, unfortunately. So it's in the fifth row of the select query, right? So below the with raw region. Right, so there's a from state, there's a from clause, and there it reads from some raw data session, a Google Analytics session table.
Yes, exactly. Okay, but how does this help? Like,
well, first of all,
either of the four things that we talked about, consistency.
Well, so this basically makes it easy to build. right? So you have your GA session table, and then you just want to will develop this step. So you create that table, you get that query, and you run it as often until it's working and produces the right results, right? So you do that in your SQL, in your IDE, where you can edit SQL queries and can have syntax highlighting, where you can try them out on the actual current data. And once it's working, then you move on to the next step. Right, so this is compared to, right, so it would be bad if you always have to run a whole pipeline just to debug and develop a single step. Right, so this can be in a SQL file, and actually that's a recommendation. And then this SQL file you schedule somehow, but for developing, you change it until it works. And if there is a bug, then you check what, for example, you can just run the CTE that gets the raw regions and see what's the problem. Okay. Right? And having an intermediate table allows you to see what the output of this is by just using your favorite database client and querying the results and see what's in that table.
Sorry, can you repeat the last thing you said?
Well, right, so if you want to debug this thing, there is a table. It's called dimnext region, where you can look into and you can see which rows this transformation produced.
Yes.
Yeah. Which is harder if you have so if you have a metaphor of where data flows from one transformation to the next, and then you usually don't see what's flowing between these transformations. Right. So the idea is you do simple SQL files that create tables. Sometimes you run shell scripts that do stuff, or some Python scripts. But in the end, that creates your tables.
Okay. And is the point of speed up subsequent transformations, is it relevant to?
That's only relevant in Postgres, but we will come that it makes sense to add constraints.
Okay.
Yeah.
Thank you.
Jonas, you had a question?
I can see some more raised hands, and also Adam raised his hand before Jonas, so maybe Adam can go first.
Okay, thank you. So I was just wondering whether there's a performance gain in creating the table first and then inserting data into it, or it's just more readable that way?
For me, it's more readable. And you also see already that I specify types, right? So I say the country ID is small int, and I also say that columns should be not null. Right, and if you just do create table dimnext region as select blah, then you have to add these constraints later on, and you might have to do explicit typecasts. Right, so it's so you don't have to do that. You can do create table whatever as select from something else, but I would say it's a bit less robust. Right, and for example, in DBT, so by definition, it's select statements after select statements. So there you have to add then a lot of metadata in these YAML files about your models. So I prefer this explicit style of specifying the types and the constraints upfront. Does that answer your question?
Yeah, perfect. Thank you.
Okay.
Jonas, you want to go ahead?
Well, thanks. So basically, I noted down, well, we have it on the slide. So you propose we have a step create table, then I do my computation, then I might add default values, and then I make an index. Wouldn't make a fifth step sense to basically have a test after every?
Yes, absolutely. Right. So we will come to testing, and it's a good question when to do them. Right. So do you do them before you put your reporting tables into the reporting tool can see them, or after? That depends a bit on how serious you take your tests. But yes, and we'll come. So for example, for me, referential. If you fail on referential integrity, then I would stop the ETL and not continue. Right. So if there's just what means just if there is some test that there's a small discrepancy between some numbers, then you might want to still show the rest of the data and then fix the problem as early as possible.
Okay.
Yes, but yeah, so that's the whole idea, to add tests as early as possible. Is there more questions? Good. Then let's move to the next part. And if you have to learn only 2 things today, this will be the first one. And I'm a bit surprised that right, so when we build data warehouse, we always make sure that this pattern is there because it will make things super simple. But in the ecosystem, we don't see people doing that. Right. So the idea is to not, right. So in the classic data warehouse and from the 90s, the data architect creates some tables manually, and then the software engineer in the basement writes scripts that fill those tables, right? And so there's always the idea of upserting and updating. So new data is flowing in, and then the table is updated, and then dimensions are updated, and so on. And this is really difficult, right? So because you have to well deal with current state, and you have to make changes to existing tables. And once you add a column, then you need to do migration. And this is actually super hard. So whoever built migrations in a backend database, it's not nice and a cause of a lot of problems and frustration. So instead, what we always do, if it's possible, to never touch existing data, but create new one. And with the important part, while keeping the last version. So what does that mean? So here we have a transformation pipeline, and at the beginning of that pipeline, you create several schemas. For example, this here is a marketing pipeline. And so what you do is you create this schema mdim next, and we will see what that comes. So this is mainly dimensional tables of your marketing pipeline, but it's called next. And then also for intermediate computations, you create a temp table. And then you write your transformations. For example, here is a temporary table it's called foo. It has then some values. And then you create maybe a dimensional entity table that is then does some transformation. And here it just adds or does some addition. It doesn't matter. Right? So then you create those tables. At the end of the pipeline and after checks, right? So what Jonas just asked. So if you are sure that the thing that you produced is correct, then you do the following. You drop the mdim schema. So the mdim is the schema that holds the tables for marketing. That is then used in reporting, machine learning, and also subsequent pipelines. And then you rename the next schema to mdim, right? So basically, you build this. You always build the next version of a schema, while people still see the last version of this mdim schema. Yeah, and this is super nice, right? So because first of all, it cannot happen that your ETL already created the add table, but not the session table, right? So the data that is shown in the front end is always consistent because this switch of the renaming happens at once. And this is more important, when your ETL breaks, then your data just gets old, right? So people then would just see, so if somewhere in this transformation steps, you get stuck because of a data problem or because of whatever, then there will not be a situation where either there are no tables in your reporting tool or where there are inconsistent tables. So right, so you just will see then the version of the mdim schema from the last time that this pipeline went successfully. And so this cannot be underestimated how valuable is to have such a thing, right? Because also in our portfolio, we see companies that when the ETL is running, then you don't have data in your reporting tool, right? So because tables are truncated in the beginning, or it can happen that well, if you refresh your dashboard in an unlucky moment, then at that very moment the table is written. So it can happen that you don't have the complete picture of in there yet, right? Or that one table was already written, another one not. And this is horrible, right? Because if people have to have intuitions about when ETL is running, and it's also horrible if something breaks and then you don't have data in your reporting tool, and then which is then super stressful for analytics engineers or data engineers, because they have to fix it then because people want to see numbers, right? So I highly encourage to always have a set of tables that are used by stakeholders, by reporting tools, by data activation use cases, or by subsequent pipelines, and never touch that when you run a pipeline, and always will create a next version of these schemas and later on swap them out, right? So yeah, Karim.
Yeah, I just find it hard to understand, to be honest. I didn't really quite get what we're trying to do. So now we have a set of tables. Suppose mdim next and mtemp, right?
Oh, these are schemas, and schemas contain tables. Right. Pardon?
Can you repeat, please, what you just said?
So the mdim next is a schema, right? So in a schema is a container for tables and functions and other objects, right? So basically, you organize your tables in schemas.
Okay.
And right, so here we create the mtemp foo table or the mdim next foo table, and you use schemas as containers so that you can swap them out later on.
Okay.
Right, so all databases have a way of organizing things into schemas, or right. So in Snowflake you have in Postgres you have databases schemas, in Snowflake you have data warehouse and then schema. And
Right.
in BigQuery, you have data sets, which is a really bad name, and then nothing. So
But
you have to use
now-
prefixes.
But now, like if I do drop this schema, doesn't it drop the whole thing as well? Doesn't it drop all the tables?
Jonas, kannst du dich mal muten?
Sorry.
Yes. So this pipeline. The public interface is the schema mdim, right? And it creates tables, for example, here the foo table. When at the beginning of your pipeline, you create the next version of that. So you create mdim next and maybe some temp schema, which you can drop all the time because it's internal to the pipeline. And then you create tables in this next schema and later on swap them out.
Okay.
So I think I will show examples later on, okay? But this is crucial to understand and to do, right? Because the alternative would be I don't have any schemas at all. I just have a big space of tables. And when I then run my ETL, I would either truncate these tables or drop them along the way to recreate them. And this will not be nice for the aforementioned reasons. DBT users, right? So there it's hard to do schema replacements. There basically you either can do once all your models ran, you can do one last step, right? Where you already prepare all your tables, and a last step copy the tables to something else, and then use only those in reporting. Or you abuse hooks or macros for having some sort of schema switching logic. Right, and so this whole thing is in line also with the idea with this functional data engineering, right? So to not have side effects, to always produce the same results on the same inputs, right? So running a pipeline means you recreate your schemas, create tables, and those afterwards switch them out, right? And then basically you don't keep a history of previous stuff. Each time you run code, you create these objects again. And if you have the same inputs, it will produce the same results, right? And so you have explicit statements for creating tables, for filling them. And this is really nice because, well, then, as I said earlier, you can easily test them locally, put them in Git, and there is one requirement for this, right? So if you always drop the tables that you create and build new ones, then it must be possible to rebuild your data warehouse from its sources, right? So you need to have some sort of a raw data layer where all the data is in there. And it should also contain all the data that you need to build your dimensional model, right? So if you have somewhere steps in your pipelines that that you cannot throw away because you do some incremental processing or you historize stuff, then I would always do that somewhat outside of a data warehouse, right? So historizing stuff, keeping stuff forever, and in this core pipelines for building a dimensional model, I would always make sure that I can always drop and rebuild. Yeah, Alexei.
Oh yeah, sorry. Just was an idea. So I see the idea behind all of this. Was just wondering if there is kind of an idea how to be able, like an ETL pipeline would mostly take a lot of time, right? And you have like multiple processes that are possibly not maybe interacting with each other. Mm-hmm. So maybe also the data is also different. And like imagine the case that you like maybe drop at some point and have to rebuild it again after fixing some error, data error or code error. Mm-hmm. And then you start to recreating the same stuff again. Yes. Just all the same data that you already computed, maybe just like if there is some kind of strategy to skip these steps, like maybe hashing functions or whatever, you know.
Yeah. So everything that contains state, right, where the current state of your tables depends on what ran before and in which order, is always hard to reason about and easily a cause for problems. I will show later that you can split all your big chunk of transformations into smaller parts that you can run independently, right? So to create sub-pipelines. These pipelines will then have their own schemas. So that you can run them independently and also test them independently. This pattern is not friendly for restarts, right? So if you restart a pipeline, you start with dropping the schemas and rebuilding them. Yeah. Again, so I think this is super crucial for me. In our portfolio, we have many companies where when the ETL fails, there is no data in the reporting tool, or it really depends on when you refresh the dashboard on what you see, and this is horrible. So the example here is Postgres. So and also, of course, sometimes you do incremental processing, right? So if you have lots of data, or you easily have logic where you do append only, then you of course also do that. But for the majority of core metrics, you do this a drop and rebuild. In Postgres, it's kind of easy to do that because they are really good at having transactional DDL. Right, so you have some problem that if you drop a schema and rename it, then there might be a problem that people are still running queries on it, right? So a reporting tool might run a query on a table, or another pipeline might be querying that at the current one. So basically, you need to function that to cancel queries on a specific schema, so that it will also have some grace period that the queries still can terminate. And then you build a function that basically for replacing schemas. In the beginning, you cancel queries on that schema, and then you basically you rename the current schema that you want to, well, that is the target of the replacement. You rename it to old, then you rename the next one to the schema name. Afterwards, you cancel the queries again because something might have happened, and afterwards you drop the old one. So this can then become a really nice one-liner where you call the function to say, please place the mdim schema with the contents of mdim next. And this works super robustly. It's really nice. If you are in BigQuery, then it's a bit less nice, or you could also say it's quite ugly. Right, so you don't have DDL statements in BigQuery for that. Right, so you have to, so for the recreation of a data set, you have to write Python code or in every other kind of language for how to do that. So you basically, well, if there is a data set already, you delete it and afterwards create it. For replacing data sets, it's a lot harder, right? So first of all, so you actually, there is no way of replacing a data set. What you have to do is you copy the tables from the data set you want to, from your next version to the data set that you want to be replaced with. So at the beginning, you create that one. If it doesn't exist, then you have to go through all the tables in the next schema and then check. Well, basically, you have to make then the other schema the same as this one. So you drop all the tables in the target schema that are not in your next schema. And then for each table in the next tables in your target schema, you will create that table as a select from your source table. And afterwards, you drop the table in the next data set. And then you run that. And afterwards, you delete your next data set. And unfortunately, this is also in BigQuery not a nice operation. So you have to wait sometimes until it's actually deleted before you can continue. Alexei, you have a question?
No, I forgot to remove my
okay,
one.
okay,
Sorry.
Okay, sorry. It's really nice in Snowflake. So they, right, so because people actually have that problem, they built actual syntax for that. So there is something called where you can swap a schema with something else, right? So these basically will, in an atomic operation, swap the mdim next and mdim, and well, so they build it in their their SQL syntax, and afterwards you create then, so because you swapped it, and then you create the dim schema. Is there questions about this? Okay, so please make sure that when you run transformations, run them on a schema that is not the schema that reporting users will see. Okay, and totally unrelated, but equally important recommendation is to avoid happy path programming. Happy path programming is that you have some intuitions what users will do in a form, or what will happen in a workflow and so on. And you program these cases, but you will you don't foresee that things can go wrong, right? And good software engineers always think about what can go wrong and assume that it will also go wrong. And imagine you build your pipeline and you create a city table that has well, a name and a country. And then you insert into that table two rows. One is Berlin in Germany, and the second is Budapest in Hungary. And then you create a second table that is, well, as a customer table, and has a customer ID and a foreign key to that city table. And then it's very, very easy to make mistakes when you create a customer table, right? So you can easily, you can easily duplicate rows by doing a self join of some table, or doing a wrong left join, or you can easily drop rows somewhere, right? So it might actually happen that you do a transformation where in this last insert statement, you introduce the customer one twice, right? So the customer one lives in Berlin and in Budapest. And you create a customer two with a city that doesn't exist in the city table, right? So this is totally normal. It happens when you process data that things do not go well. The problem is if people query these tables, and with people I mean both people that use reporting tools, but also you, the person who writes pipelines, right? Who might use that table in subsequent processing steps. all of them will have assumptions when they see such a table, right? When I see a city table, I think, okay, well, well, there should always be a city name, and I think there maybe they're also, depending on the business case or the use case, there might be also unique. And I would expect that if there is a customer and there is an ID of a city, I would really expect that the city exists. I also would expect that in my customer table, that I don't have two customers with the same ID, right? So these are, well, good assumptions that downstream consumers of these tables have. And then also they will, right? So if people write queries, they will not account for or will not check whether these things are unique, right? So if somebody, for example, wants to do an analysis and count the customers per country, he or she might write a query that does exactly this, right? So it joins the customer table with the city table on this foreign key, and then counts the rows and groups by country name. But if you have data in like the one below, it's really hard to reason what the result will be, right? So it's a total mess. That's why. And it's only very little overhead, and will really kind of save you time and frustration. Basically, we always back up the consumptions, well, the assumptions that you have about data, you back them up with constraints. What does that mean? Right. So first of all, you add a primary key to the city table, right? So that means that makes sure that there is no null values in the city ID, but it also makes sure that each ID is only once in the table. And then you also, well, can add unique constraints, right? You could say, I want my city to be unique. And then you also might want to make the city and country unique. That becomes then a bit of a problem when, for example, you have 15 different Neustadts in Germany, right? But so it's something that depends then on how you want to use this data in subsequent transformations or reporting. Also, you add things like primary keys to the customer table, right? And if you do that, you will immediately get a warning that the customer one is duplicated, right? And doing that already at this step, well, right, so it might be even that there are no problems in further transformations, but the likelihood that things will go well is really downstream. So you was a question also of Jonas, should you continue? Yes, at this step you should stop. Well, if there is if this customer one is duplicated in the customer table. And you also add foreign keys, right? So you say, okay, if I have a value for a city ID in my customer table, I really want that the city also exists in the city table, right? So you add a foreign key from customer to city, and if you do that, then the database will tell you that the city number 3 is not present in the table city, right? So I encourage you to always do that after each transformation step, right? So here it's declarative. So if you schedule the declarative queries, then you do this. If you do DBT, then you just have your select statements, and then you add unique constraints and other constraints in the YAML file that goes with the models. Is there questions about this, Karim?
Yeah, so again, I'm confused. I mean, so now what did I do to avoid happy path programming when I packed up all assumptions about data by constraints?
Well, then you basically, right, so happy path programming would be to not have constraints and just assume that customers will be unique and that cities will exist. And by creating these constraints, you avoid happy path programming.
Okay, so the idea is to actually have constraints in the first place. Okay, cool.
Yes,
but
that's the idea. Yeah.
But for example, these last two constraints which produce the error.
Yeah.
Why did I put them in the first place? Or was the idea to actually have an error,
The idea is to have an error because the data in the customer table is crap, right? And so you don't want to show that table to users, right? Because the query above will produce random results. And you don't want to use that table in subsequent transformation steps.
You mean the query above, the one with the customers per country? Or
That one, yeah. But anyway, so if you have the customer table, like the one at the bottom left, you should not stop. You should stop the transformation and not continue. That's the whole point. Okay.
Can I also just quickly?
Please, yeah.
Sorry. Is it possible to add these constraints right after creating the table?
No, you do that later.
So in order to what?
You normally do that later because the other table might not exist yet. Right. So this is it. So right. So if you in parallel create tables, then it can be that so you would normally create a city table and the customer table in parallel, and then depending on how they are scheduled, it could be that the other one doesn't exist yet, so you do the foreign key constraints in a later step, usually at the end of the pipeline. Okay,
yeah,
but I was
thinking about like.
Yeah, I will show that later. Okay. Okay. So not only for tables that are consumed in reporting tools, right? So this was already a kind of final entity table, but also for any kind of temporary table, always will at not null constraints also think about unknown values, right? So before the table had nullable columns, and why not always adding not null constraints to these tables? So it will make things a lot easier because you assume that each of your orders has a payment method or has an order date, or that each of your customers has a name or an email. But it could easily happen that it's not. And if you assume that a customer needs to have an email, make it not null in all the tables that are concerned with customers. Right, so it will make it easy for you to detect problems very, very early on. Right, so in the case of the city table, you would say, no matter how I create a table, I want the city ITB to be not null, maybe also already unique, that I see problems already when I insert those. And I would also want the city and the country to be not null. Right, and the second thing is sometimes you want to. Right, so sometimes it really happens that you don't know what the city of a customer is, but then you might want to create a kind of city that is then a catch-all city for all of these customers where you don't know. Right, so then in the example above, you would then in the customer table, you would also make all of them not null, and in the customer table, you would insert then the customer 1 in Berlin, and for customer 2 you don't know, so you make it -1 as the city ID, and so which then references this unknown city. Right, so these not null constraints, so add them always. For me, there needs to be a kind of justification from the business requirements when the column is nullable, right? So a product should always have a product category. If you don't find one, it should be the unknown category. But for example, an order does not always have a shipment date, right? So there it's justified that it's null. An order should always have some sort of price column, right? So I think for me it's rarely justified if it doesn't, but doesn't always have to have a voucher value column, right? So, so the default should be to make columns not null, and you can do that in all databases, and consciously deal with those cases where they are nullable. And this helps you, but this basically helps you that you detect problems very early, so that if something is weird in your data, you don't notice it very late in your pipeline, or even then have your users notice it. Unique constraint, the same thing. When you think that something should be unique, add a constraint, also in temporary tables, and you could even do that in data tables. It will really save you runtimes and cost. So 2 weeks ago, we had something where a query was slow, And then basically that was because somewhere there was a table that was supposed to have unique values on, I think, on the product category level, and actually was supposed to have only a few thousand rows. But because of some problem in the previous transformation, it actually had 300 million rows, right? And so then things become slow, or it can become, right? So it becomes slow in databases like Postgres, or they become very expensive in databases like Snowflake. And just adding unique constraints also on these intermediate temporary tables, well, will save you time, but also will save runtimes and Snowflake costs. And these unknown values are good because when people, right, so people have a diagram of revenue over time, and then they add the country dimension into the chart, and people expect that the overall sum of this of the revenue over all countries is the same as the revenue that we're seeing before, right? So adding another breakdown should not change the sum of the metric. And so if you have the situation that you just don't know the city for some of your customers, make it explicit so that in the graph you will have then a proportion of unknown countries for your customers, but with the nice property that revenue still stays the same, no matter whether you whether you break it down by country or not. Is there questions about this? No. Okay. Then never ever repeat business logic. And I cannot state that often enough. So even in sufficiently well-maintained data warehouses, I see corners where business logic is repeated, and this is not good and will make the things that you build unmaintainable. Right? So never ever do that. This is an example from a data warehouse that we built already, I think, 5 years ago, where we had to iterate very, very quickly. In fact, this was it was a company called Treatwell. It was the fastest exit of Project A ever, I think only after 6 months after investment. So we were iterating very quickly, but then make mistakes along the way, right? So there was one part of the data transformation pipeline where there was right. So there was a query on this order table, which was the raw ingestion table for orders, and there was some revenue computed, and it was done so if the order had the status impending, accepted, completed, or proposal for change. Or in another part of the pipelines, there was something reading from the same order, and there was the notion of being processed, which then it was processed when the status was not started and the payment status was authorized and the order type was backend. And I found a third part where when the last status is pending, then it's unprocessed, right? So, and this is 3 different intuitions about what an order is and what's processed and what subsequently is then revenue. And if you have that, then well, you will get nowhere. So never ever do that. If you have business logic about what a processed order is, don't put them in several places, but refactor your pipeline so that there is a single place or where you create a separate table or task that computes everything you know about an order, right? So where you can compute, is it processed or not? And then maybe also make the right decisions about which columns to use for computing a revenue and. Is there questions about this? Right, so just don't do it. Right, so even if you are sure that you use the same duplicate business logic in different parts of your pipeline, it's horrible, because if somebody wants to change it, then he has to find all occurrences of that business logic, and the likelihood of that happening is very low. Right, it's the same as relying on people updating the same business logic in different charts and dashboards, as we discussed yesterday. So how do you deal with it, and how do you make sure that things are computed only once? Right there, the recommendation is usually to organize your processing steps somehow in layers, and this requires disciplines. These layers are also sometimes called stages of a data warehouse, and they can correspond to, they can even correspond to physical databases. We will come to that. Right. So, but in a nutshell, what you typically have is that you have something where you ingest all your raw data, and then you load that. Then you might have optionally a phase where you clean things. Then you have the phase that we call a pre-process. And I'll show that in a minute what that means, which is then where all the business logic sits. And there's something called transform, which creates then the Kimball-style dimensional tables in the database. And then there's a flatten phase where you do things to make it look nice for reporting tools. Right, so if you have this trinity of e-commerce product, order, customer, then you have something that is able to get this data into a data schema, or it's often called landing area or whatever, right? So where you basically get a more or less exact copy, unchanged, of these raw tables, right? So how they arrive there doesn't matter. It can be via a direct copy, it can be via change data capture, or via event streams and so on. Right, so but you basically have tables then in your processing tables that reflect or that are exact copy of the raw data that you have. Then you can do some cleaning, right? So you can remove, for example, test orders, and then also remove test customers, or then also remove the customers the orders of test customers. You can also then, right, so turn timestamps. You can turn epoch timestamps into nice UTC timestamps. You can remove white space around strings, or turn empty strings into null, and right. So this can happen at the stage of cleaning. But here I wouldn't do business logic, but just say, okay, I need a kind of clean representation of an order, because I want to use it then elsewhere in subsequent transformations.
Sorry?
Yeah, sorry?
Yeah, so should we already merge things in the cleaning step in that case, or is it,
no.
should the cleaning be applied to the different tables and then just temporary tables?
So you only apply them to these order tables. You don't change the original table. You create a new table that has the cleaned version, right? So you never change previous stuff. But you might join, right? So for example, if you want to if you want to remove the orders of test customers, then you have to already look at the customer, right? So that's what this arrow here means.
Okay.
Yeah.
Thank you.
Then you have the actual business logic, and at Project A, we call this pre-processing because it's not the final dimensional model, right? So it's all the business logic that you want to apply, and everything you know about an individual order, about a customer, about a product, without too much looking at other entities, right? So here you compute whether the order is processed. Here you compute the voucher value. Here you deal with cancellations. For the product, you collect all the attributes, categories, bring them together. And for the customer, well, it's everything that you know about the customer, but you don't do this kind of integration across different domains, right? So at this level, you don't compute the customer lifetime value, right? And at the level of order, you compute it, but you don't already establish a link to the customer. Or for the customer, you don't compute the favorite product. So you compute the things that you know about these entities in isolation. Why in isolation? Because you want to be able to parallelize these computations, right? And also you want to be able to deal with circular dependencies between entities, right? Because a customer can have a favorite product, an order has a product, an order has a customer. So if you do things in sequence, it will become hard to untangle these circular dependencies. So you have to find a way to separate the business logic about individual entities from these transform steps. I will show examples. And then it's what we call then these transform steps. Actually, it's not really a data transformation anymore, but it comes from, I would say, yeah, well, from conventions in dimensional modeling. This is now the Kimball-style model, right? So you, in the pre-process step, you have booleans, you have strings, you have timestamps, and here now you have, when you have IDs, here you have now foreign keys to other tables. You have attributes, you use enums, and also here now you compute the revenue of a product in the last 30 days, right? So because you do a transfer of the revenue from the pre-processed order to the product. So you do all of those. And then, because these dimensional models are often not so easy to consume by business users or other tools, you do then some sort of flattening where you bring the data in a shape that it's best for the people that consume them, right? So there is no business logic at all. It's just taking the dimensional model and bringing it in a nice shape so that it's easy to consume. Is there questions about this?
For example, marketing attribution. Where do you do this in this model?
Yeah, so it's in the pre-processing step. And of course, it's then 5-6 layers of pre-processing steps. Yeah, so this is an ideal picture. We never build a data warehouse like that. It's not possible, but it's a kind of well, mental role model to have in mind. Yeah. Also, these separate layers can normally correspond to different schemas. And sometimes also different pipelines, right? So you could do the load part in a separate pipeline and then have that in a kind of raw data schema, right? So the cleaning and temp pre-processing usually happens in a temp schema, right? Because they are internal to the pipeline. These transformations then happen maybe in this dimensional schema, which is another one. And the flattened ones can be, again, in the reporting schema or even in a different database, right? So for us, so in the past, we like Postgres a lot, but of course, nowadays use BigQuery as a kind of ingestion layer or data lake, right? So the data, we would load it from BigQuery, then do all the stuff, and in the end, in the flattening step, create the final tables in BigQuery again. Okay, I think we are good in time, so I can show lots of examples. Two things. Never query data from more than one layer above, right? So I'm not telling names here, but I've seen it in the last weeks again, where right, so there was somehow these layers were followed, but then there was a fact table created in the end that again joined some raw data tables, right? Or where there was a table created and then another table of that and that, but still the previous tables were all joined again to that thing. And this makes it, first of all, very expensive, right? So this results in high Snowflake bills, but also makes it really hard to reason about data lineage and so on, right? So if you need one more column in your customer fact table at the very bottom, and you have that column in your raw data customer table, don't just join the raw data table and add this column to each of these intermediate steps, right? And well, this will save cost and runtime, will make data lineage easier. So it's really important to not join previous tables that more or less are the same granularity. Move all the data that you need along these stages, right? And don't join raw data again when you are. So if you join raw data again, then you basically skip the cleaning step. And so whatever you do in cleaning, it really depends then on random choices you make in your left joins. Yeah. And the second important thing is compute things as early as possible, right? So your boss comes to you and says, I want to have a different logic for segmenting or for creating the customer segment of a customer, or a categorization. Right? For example, you could say it's a loyal customer or not. And the easiest place to do that would be after you flatten your customer effect. Right? So it's always the easiest to create business logic at the end of your pipeline when you have already all these nice tables and you wait. So the customer effect has everything about the customer, but also about its orders, favorite products, and so on. So it's super easy to compute a loyalty score or everything else there, right? But this is horrible. So don't do that, because it will make your pipelines unmaintainable, right? I've seen a drastic example 3 weeks ago at a company where there was a nice aggregated session fact table, and it was called in a schema called truth. But then somebody, I guess, because of time pressure and they needed to get something done, created another schema that was called post-truth and created another table for marketing sessions that again had a lot of different random business logic about how to compute things. And this is a nightmare if somebody is then tasked in changing anything in such a pipeline. It also, right, so if you always add stuff to the bottom, then this will increase your pipeline runtimes and also cost. So try to apply business logic as early as possible, right? And if you need some information in 2 different parts of your pipeline, create a separate intermediate table that holds that information and then use it in subsequent steps. Is there questions about this? No. Then let's come to examples of how that actually can look like, right? So here, this is the picture of, this is an ideal picture. And as I said, it's very unlikely that this will ever happen. So here is one in reality. It's the pipeline for everything around customers. So Trentro is a travel company where elderly people can do bus travels to the Lake Garda in Italy. And right, so there are bookings, customers, travels, and so on. And at the top here, you see these clean steps, right? So for example, here, there is some table called RSD. And basically here's one step where everything from that table is deleted, where the travel ID is between 2000 and 6000. Why not? I don't know what's the reason, but right, so already at this step, there is a new table that is a copy of the raw data table that doesn't have these travel IDs, right? And this is nice because then this filter doesn't have to be applied in subsequent steps of the pipeline, right? So then there are more cleaning steps, and then here you see these pre-processing steps. For example, here is something that pre-processes a booking. So booking is the main transaction. Here you see all these columns that Trentro knows or wants to know about a booking, right? So here are booleans about whether it's a customer canceled thing, and then, well, I will not go through it, but here is a lot of business logic about bookings, right? So, for example, here is something, when the bit internet is true, then what actually is this here? Well, I guess it's some column about or some data source and so on, right? So business logic in SQL usually doesn't look nice. In fact, it often looks ugly. The important thing is that all the ugly business logic about bookings lives in one single space, right? Then here is another pre-processing step where there's a temp table about travelers. Again, booleans, timestamps, and so on. And, well, more business logic, right? So if the status is 0 and the previous status is also 0 and the status is also 0, then it's company canceled. So I don't know what that means, but for me, it's nice. What's important that this notion of a traveler being company canceled is in a single space. Then, right? So here you see then, so it's fairly well distributed, so that things about travels are pre-processed independently from tours or from whatever. I think I know what a mailing person is. Or mailings, but right. So so this is actually, so for this is really, for my opinion, done really well. So you don't have, right. So how does a bad pipeline look? A bad pipeline is where you basically have a long vertical chain of stuff, which, right. So where you have many layers from top to bottom. A good pipeline is very wide, so many things happen in parallel, which makes things easy to change and to reason about. Also, the namings here are good, right? So I know that this here is about cleaning. I know where to look for, right? So if I want to understand how bookings come about, then I have to, okay, and I look for this pre-processed booking. I look what goes in those transformations, and then later, does somebody see the transform booking? Doesn't matter, right? So then I have a search function.
It's just before the transformation complete at the end. Last bill.
Here.
In the middle, yeah.
Transform booking, right? So in the end, you create then these dimensional tables where you don't have booleans anymore, but well, you have enums and you have foreign keys to dimensions, and then, well, I don't know what this is, but so basically you don't do business logic anymore, but you join all these things together and create a dimensional model. And in the end, you create a lot of foreign keys to other entities. This will then result in a nice Kimball-style schema. Oof. Right, so here is the really long booking table, and it has then foreign keys to vouchers, to dates, to customers, tours, and right. So maybe I showed it rather like this. So this is then a nice, not trivial Kimball-style model, but the point here. So this is done well, I would say. And I think we don't have time to look at another one. Another one is really well. I want to show it, but I think let's rather move ahead. Next big point is, right, so as I said yesterday, it's very easy that you not only if the business is sufficiently non-trivial, then you very quickly will have 50 different analytical entities, and then at some point. You don't want to compute all of them in a single pipeline, right? Imagine you have your marketing touchpoints, your customer service requests, your product status changes, and you do them all in a single pipeline, and then right, so then we can become well, it can be really hard to debug things, but because in order to get to the point where you see your syntax error in your SQL query, you have to run all the other stuff. Right, so mainly for reasons of splitting concerns, you create separate pipelines for the things that you either want to develop independently, right? So normally, for example, here there is a Zendesk pipeline, and if I'm working at entities around Zendesk, I don't care about Criteo campaigns or about orders and so on. So right, I basically want to be able to develop their pipeline independently and run only that on my local machine, or also in a testing system, right? So I don't maybe want to run the whole thing if I just want to do QA on my Zendesk pipeline. And also sometimes, right, so sometimes you don't want to run all your transformations all together because it might be expensive or because the data might not change, right? So often, for example, if you use Google Analytics, then you typically only get new session data once every day. So it doesn't make too much sense to recompute your attribution every hour or every 30 minutes. But often you have things like your core order metrics or other things where you want to act on the data that you have intraday. So you might want to have something where you run your whole ETL at the end of the day or twice a day, but every hour you run a subset of these pipelines that update data about customers and orders. When you do that, when you build separate pipelines, then you really have to make sure that you will follow this immutable functional data engineering patterns, right? So basically, if you split transformation multiple pipelines, make sure that each of those writes into a different schema, right? So don't do one big ETL schema where all those pipelines write. Create schemas for each of them and make sure that each pipeline only writes to their own pipelines. So never write, right? So it would be really bad if, for example, the Zendesk pipeline makes changes to the operational systems pipeline, right? So for example, by adding stuff to a customer, right? So for example, very easy, you could have something where you have a customer table in your kind of sales core entities pipeline. And in that customer entity, you have a column that's called number of DIXA service requests. And then it would be really bad if the DIXA pipeline kind of writes to the schema of the operational systems pipeline. Why? Because then you lose this property of item potency and repeatability, because then the status of the customer table depends on whether, not only depends on when the operational system pipeline has run, but also depends on whether other pipelines have run afterwards. And if you then have bugs there, these are super, super hard to find, right? So really make sure that each of these pipelines only modify their own parts of the database and never write somewhere else. If you need the number of customer service tickets on the customer table, have another step later on that combines the customer table, the data in the operational systems transformations with the customer service transformations. And lastly, avoid circular dependencies. It's super easy, right? So you write a transformation early on in all these pipelines, and it's super easy to reference data from tables that are created by data pipelines, right? So for example, you could, in this operational systems pipeline, do a join to a table that is created in this DIXA customer service pipeline, because normally it's already there, right? So you already ran the DIXA pipeline before, and then you reference that in a previous step. This is really bad. For example, if you want to, so basically you want to start from scratch, you want to check out your pipeline code on a testing system where you don't have the subsequent tables yet, then this pipeline will fail. That's the easy part. So basically, if you have circular dependencies, then you lose the property of being able to recreate your data warehouse from its data sources. But also, it's, as I said, it's really hard to reason about what now exactly is the number of customer service tickets, because in this step, it depends then when the DIXA pipeline has run the last time. Is there questions about this? I can also show it, right? So this is from HelloPrint, right? So each of these boxes are one sub pipeline. So here's one pipeline that basically just loads stuff. Then there's the pipeline, here's the pipeline of computing. It's actually the computing these interesting order metrics that we seen yesterday. And then here's another, I guess it's really small, one that computes stuff. Oh, it's really big, about customer service requests. And then there's another one, I don't know what's that doing. Here's one about marketing. Alex, that was your question, how you do attribution. It doesn't look that nice, right? So you have these pre-processing steps about ads from various marketing partners. Then you have session logic, pre-processing of touch points. Then you have the whole part of the campaign structure. Here is attribution, and here is marketing cost checking, and then eventually there are touch points flattened. Adam, you have a question?
Yes, just was wondering if this tool is applicable to every database, or how do you visualize the connections like this?
I mean, every every kind of task scheduling tool has a way of visualizing the DAG, right? So DBT has it, Airflow has it, and Mara has it as well. But right, so it doesn't matter which scheduling tool to use. It's about how to schedule how to structure pipelines, right? And so you can do the very same thing with DBT or with any other data tool.
Okay.
Yeah. Right. So this is Mara, which is well yet another data pipelining tool plus more. Yeah.
We have one more question, I think. Michael?
Yep.
Jimmy?
Can you hear me? Yeah, yeah.
Yeah.
Yeah, I mean, all of that sounds totally right to me. I was just wondering about when you said like idempotency and circular dependencies. Is it not also, I mean, I'd often take the approach of saying individual steps are basically individual steps self-govern or self-know about, you know, the state of their interaction with other things. So for example, they know whether the underlying table they're supposed to be doing an idempotent insert into exists or not. And then, I mean, that's the DBT idea, right?
Yes.
You move it back towards the select statement, and then it can have a knowledge of, you know, a few different tables that are that dictate whether or not it could be idempotent and which behavior it has to do in order to get to the valid state or the current.
Yes, yes. So if you have this metaphor of DBT where the whole DAG is created as well of references and select statements, then you automatically avoid circular dependencies.
Yeah. Well, you don't. I guess you don't also automatically avoid them, because I think another point you made.
It can be subtle. Yeah.
But I think they could be used. This point you made about like, you know, if you need the users table to, you know, reference some actual aggregate number, like, we basically need a dimensional, which I hate and hurts my feelings and it's hard to figure out. But like where you need, like, we want to categorize our users in a dimensional way from basically a fact of some other aspect. I think, well, from experience there as well, like I put upper caps on time related stuff, so that you mentioned this thing about what if we're going to get out of sync because when ran in which direction. And I find one thing we often do is we go, greater than the last load. But I think it's also a good idea to go, you know, have a flag table for the beginning of your load process and say not greater than load process start. And that means that, yeah, even if they're sort of out of sequence, they don't go past a certain level of maturity. You don't have this kind of, oh, well, this is because it ran 10 minutes ago and this is because it ran at the end of the day or something.
Yeah. I mean, there are lots, right? So this year is heavy, right? So it's really lots of different business logic. And as I said, so the whole thing of best practice is about coping with complexity, and it's very natural. There will always be complexity, and you have to weigh in whatever tool you're using to run queries. You have to kind of be aware of these complexities and deal with them. And there's okay. Okay, we have half an hour left. That's nice. Okay, we covered that. Or is there more questions about this? Sorry. Okay. Then write tests. Right. So every software engineer will tell you that if you have tests about your code, then it's easier to change things without breaking stuff that used to already work. And the same applies to data analytics engineering. And many people think that they need to introduce a tool for writing tests or need to have some data governance product or software as a service product? I don't think so. Having tests is just a matter of doing it. And no matter what your database is or your scheduling tool, there's always a way to create tests around the consistency and correctness of your data. Right. So here, you could in Postgres, you could easily create a function that tests whether the result of two select statements is the same. Right. So here we want basically check whether, so we have an order item table in our dimensional schema, and we want to make sure that the number of rows in that table, which we checked for referential consistency and where we did other tests on, whether that one ended up correctly in the order items fact table. So basically making sure that we didn't accidentally lose some rows but with a bad join. And right, so then you run that and you compute these two counts, and well, in the passes if the counts of those are the same. In dbt, you create tests by writing select statements that should return null or 0 as the result. So basically, you would write a query that does the select count from the order item and subtracts the count from the order item's fact. And so if the difference is 0, then the test passes. If it's not 0, then the test will fail. Right? In Great Expectations, you have more flexibility of how to formulate these tests. So the point is, it doesn't really matter. So it's not a question of tooling, it's a question of discipline to formulate and write tests and also keep doing so, and not to comment them out when there is a problem. So I see this all the time, that some good soul wrote a pipeline and then wrote tests around it, and then somebody takes it over. And of course, over time, the distribution of data and your input changes, or other things change in your business. And then at some point, the tests don't work anymore, or there's some kind of operational hiccups somewhere. And then rather than fixing the tests, they get commented out. And this always makes me angry. I don't want to name names, but there are many portfolio companies of Project A where rather than having an increasing number of tests, the number of tests becomes lower because people are annoyed that the pipeline is failing because of tests, and then fix that by commenting out a test. So don't do that. Right. So here the easiest part is just making sure that you don't lose rows. If you do stuff, for example, where you do a transfer of metrics from one domain to the other, make sure that they sum up, right? So, for example, here you want to make sure that the number of first orders from some order table is the same as the number of attributed first orders in some marketing pipeline divided by the number of attribution models. And you want the difference to be less than 0.1%. 0.01%, right? So you allow, because there are rounding errors in databases, you allow for some margin of error. Right, so if you have assumptions that your AdWords campaigns always contain a channel attribute because you rely on that, then you make a test that, in fact, all your ads that had some impressions in the last 30 days should have this channel attribute because you need it later on, and you want to alert people that this has not been the case anymore for specific ads. Or if you do stuff where you're in a pipeline, for example, here distribute costs from some touch points to the others, you still want to make sure that in some it's the same, so that you didn't actually make a mistake somewhere. Is there a question about that? Yeah.
I assume that's me again.
Yep.
Yeah.
Please, Timmy.
Yeah, tests are really great. Again, I find them quite hard to reason about compared to unit testing in doing engineering. Like you're kind of unit testing an entire column a lot of the time, which is the way I think of it. But the question I'd have about the testing mechanism that I find difficult in situations that we have sometimes is particularly when you're making changes and you have these tables that are prohibitively big, like to rebuild entirely, let's say, and so your testing suite or your continuous deployment suite is going to have to run on a section of the table. It can't do full integrity because we're talking about like resessionizing everything, which is just not going to happen. How do we reason tests around that? Because I kind of come into this situation where there's production tests which run and make sure the pipeline shuts down if like something's going to cause a terrible cross join and the production data. But these same tests then kind of give maybe false positives because they can't run across the whole data set anymore. Have you ever come across in the context of the continuous deployment?
Well, we don't run tests. So for me, this is part of the pipeline, right? So it's not when you deploy, but it's every single run of your ETL that you include tests, right? So because you not only change code that might affect the tests, but also there might be changes in the data that also can cause tests to fail. So you don't only do it to when you deploy.
No, yeah, I get that entirely. I mean, they're two different things. I mean, we can try and use the same set of, what I'm saying is often I try and use the same set of tests to achieve both goals. Obviously, like the biggest thing that everyone experiences straight away is, oh, all of a sudden the devs aren't filling out this column that way anymore. And you want to catch that when it breaks your pipeline in the morning and basically shut stuff down until you fix it. That's one thing, that's nice. But then what about the second thing, which I try and move more and more towards, which is like, how do we know that now that you've done this, you're not creating a horrible cross joint? And how can we catch that before the morning? Because that's not the dev's fault. Like, how can we catch that while
okay, so you mean that somebody wrote a query that does a horrible cross joint that will halt the database?
I mean, any number of mistakes.
Okay, so I will come to that. So this you do by not testing things on production. But I will come to that.
Okay, I'll ask you when we come to that.
So yeah, that will be the second to next slide. Also about unit tests, these are not unit tests, these are rather integration tests, right? So they're basically, you run the whole thing and then you check whether the data is still there. We didn't have the case where these tests were so heavy that you couldn't run them. Sometimes, for example, here, if you really go through individual sessions and sum up some attributed values, then this will run for quite some time. So you run it maybe at the end of the pipeline, also after already you updated your reporting front ends, because you don't want to wait for the tests, but you still want to know whether something is wrong. Right? So that's a decision to make, right? Because sometimes these tests take some time, but you want to already refresh the data, and you hope that in most of the cases it's fine, and then you will notice and fix problems afterwards.
Yeah, okay. Yeah. I think I'm more talking about the case of trying to check some aspects of these during the code that you're deploying. So I think I'm referencing what we're going to talk about.
That's a different topic. Let's come to that.
Yeah.
Okay. Other questions about testing? Please do it, and at least don't comment out existing tests. It always makes me sad. Then almost last point. Right, so if you build that dimensional Kimball-style star schema, then that's not very user-friendly, right? Because, for example, if you want to know the revenue per favorite product category of the customer, that's then you have to do a lot of joins. And well, some analysts are good at SQL; they're happy to do joins. Some are not, and also some reporting tools like, for example, Power BI. They are good at a Power BI or Looker. They are happy about such a representation of data. Other tools like Tableau or Metabase are not too much, right? And so basically, you build that Kimball-style schema to have this conceptual clarity, to have referential consistency, and to have correctness. But afterwards, you do whatever with it, right? So for all the different data use cases that you have, you bring the data in the right shape, right? So you join all these tables together and take attributes from all of these tables and create one wide flattened table. And then you can make choices about whether you want to call the customer ID column with a space in there and with capital letters or not, right? So Tableau likes that, Power BI doesn't. And you can do things like whether you want to pre-compute metrics like revenue or not, and. So so basically you kind of, it's totally fine to have 5 different versions of an order item data set lying around somewhere, as long as they contain the same data and they can be in different shapes that are right for the consumers, right? And so don't require your downstreams to consume from this dimensional model. Right, so we nowadays create these statements from a schema that we have in Python, but it's also totally fine to write them by hand. It's just a little bit more work. The questions about this? Okay, then never ever develop or test in production. That can be super stressful. And in the Project A portfolio, we have 2 companies that are unicorns, that but they both only have one, let's say, database environment where they run everything in, right? So there is only one data warehouse, which transformations are run. And if people want to try something new, then they try out their queries in this data warehouse. But then more or less, once they think they work, they put them into production, and then they either fail or not. And this is for me an absolute, well, it's really a productivity killer, because rather than, right, so maybe to say first what you do instead. What you do instead is, for every developer, for every data engineer, for every analytics engineer, you make sure that he or she has his isolated environment where he or she can run all the queries and try out things without affecting anything whatsoever that runs in production, right? So if you are in Postgres, you even can do that on your local machine. In Snowflake or BigQuery, you create for each developer a separate data set in BigQuery or data warehouse in Snowflake, where that person can write and change stuff and can run whatever he wants without running in production, right? So then you take your pipeline code that you have in Git, create a branch from it, make your changes, you test those changes, and then once you think they work, you also put them on some kind of staging or testing system, which again is independent of the production environment, where you run the pipeline that you have on all the input data that there is, that you have in your raw data storage. And then once that works, only then you put it in production, right? And so this will, for example, very easily help you detecting that somebody made a join of a table with itself, because it will not terminate or otherwise blow up. But basically, well, structure your data warehouse in a way where you have more than one environment, so that you don't have to wait when things end up production. We don't have to wait for problems to show up there. I hope this is right. So this is the same as software engineering, right? If a front-end developer that develops a website doesn't write code and then uploads it to production and then see whether there's problems. No, he has, first of all, he has a way of running the code on his local machine, so that you very quickly can iterate from changing the color of a button to seeing it. But also, once he has that, he first puts it on a staging system, where then product managers and QR engineers can look at it and discuss it, and then make refinements, and then it goes forth and back. And only if everybody is happy with the color of the button, then it's deployed to production. And right, and this is super obvious. So everybody would think it's crazy if the front-end engineer would make change the color of the button live. So that would be called crazy. But in data engineering, it's more or less the norm, right? So, I mean, in the Project A portfolio, when we were involved, we kind of, don't do that. Right? So also with when we use DBT, we also make sure they're separate environments. But we see a lot of data stacks or data infrastructures where there's only one environment, and I think it's as crazy as changing the color of a button of a website in production. Is there questions about this?
Timmy, please.
It was always going to be me again. Yeah, no, totally valid point. And I guess we are one of those people you mentioned, to be honest.
Yeah, there's quite a few cases, and
but I think as well you listed this, like if you're using Postgres and you can fit your data into Postgres, then you can replicate your data. If you're using BigQuery using Snowflake, then also they have decent replication systems where you can set stuff up. The problem for us is Redshift itself, I guess, because it's really hot. Like what are you doing when you want to test across like 10 billion events? It's like, and you want the code to be able to check, is this next incremental load going to work, or is it going to work on past stuff? I guess that's the challenge we have, but I guess you maybe answered it. It's Redshift is falling behind there.
Yeah,
it's because it's super slow to replicate. Like you can't, like even the CI, like we have something where we try and like intelligently figure out deltas, which is just dodgy.
So nobody uses Redshift to start new projects. Yeah. There are people here in Berlin that work on improving Redshift, right? So they also recently did this decouple of compute and storage, but well, it's a big decision to migrate somewhere else. But I think there's a good case for doing so.
Yeah, no, this is a real.
But we said we don't want to talk about databases today.
But it's the thing that messes this up for us, I guess.
So please take home, don't develop or test in production. Okay, so we only have 10 minutes left, but it's also only 2 slides to go. So the question is, right, so there's all these abstract things, and you've seen these kind of developed data warehouses where there is already a lot of complexity, but how do I start? How do I build my first pipeline? And well, and I hope you learned that from yesterday. What you never ever do is to kind of look at the structure of your backend tables and then, okay, what data do I have in there? And then create entity tables for the things that people might need. You might think that that's obvious, but, and also in the Project A portfolio, that happened, that kind of data engineers don't really talk to stakeholders what they need, but they just build something. And the chance of this somehow creating business value or being relevant to business users is very, very low. So don't do that. So don't just build something that you think people might need, right? So, which is the same in software engineering. You don't just build a website or you just don't build a feature where you, out of some idea, you basically have product managers who kind of try to figure out what users, okay, maybe they do also this kind of guessing, but it's different. Okay, what you do instead, and you learned that yesterday, you go out, collect business questions, and derive these analytical entities on paper. When we do big projects, right, we typically have a delay of 1 month or 2, right, so that we first have analysts doing this process. And only 1 or 2 months later, when these things are clear, then we start building stuff. Right, so should be obvious, but yeah. And then, right, and so then you start building it, yeah. So and also you do that incrementally. So you don't do this kind of big waterfall planning where you plan your whole data warehouse schema and then kind of write a big book about how that should look like and then give it to the data engineers. But you do it step by step because nobody is good at waterfall planning. 10 years ago, it was at Rocket. There was a BI team that was actually doing that. So they were writing a book, how the data warehouse at a company should look like. And at the moment they were finished, the business models of these companies already changed twice. So it was completely obsolete. So that doesn't work. Again, right, agile methods really work here. Right, so you do things, you start with something and then add entities, metrics, and attributes step by step. Right, so this is here the evolution of the entities, the analytic entities at Ammann Görbach, where we started building a data warehouse half a year ago. right? And we started with one entity, a customer, that had already a zip code dimension. Then we added something. So Aman Gerbach produces machines for companies that produce artificial teeth. And so a case is something like somebody wants to have, a dentist wants to have a teeth produced, right? So you add then this case thing, and then there's employees working at dental labs. Then you add patients that belong to a customer. Michael, can you mute yourself?
Timmy, please mute.
And right, so you step by step add entities, add columns, and so on. And by this, and in each of these steps you test, you do QA, and this is, I think, a much more sustainable or kind of manageable approach than building everything at once. How to actually start? Right, so I would say you basically copy something that exists. For us at Project A, it's super easy because we have been building data infrastructures for more than 40 companies. So we basically can always reuse things that we did at previous portfolio companies. If you are not in this luxury situation, then you look on the internet. There are lots of good templates for data warehouses, right? So there's lots of examples for how to do stuff in DBT. Here is an example for how to do data warehousing in Mara. So this is basic. I think we have 5 minutes. I will quickly show it. So this is something you can download, install on your machine, and then run it. So here it's based on data from a publicly available Brazilian e-commerce data set. And then you have your two pipelines that load data. And then there's a really small pipeline that will transform something. It results then in a kind of tiny toy Kimball dimensional model. It's actually the one that I was showing in the two presentations today and yesterday. And some other things. So I would say this is basically, I would say, the Project A data modeling best practices cast an example data warehouse. Right? And so even if you don't use Mara, you can still look at it and use the conventions and the way of structuring pipelines for your project. Please have a look at it. Lastly, so if right, so all of this can look very confusing and is difficult, and so if you are in a situation that you need help with this, then the Project A data and analytics team, so this is how it's called since the beginning of this year, is always there to help you with this. Right? So we have done this with lots of portfolio companies and made lots of mistakes along the way and can help you to avoid making the mistakes that we made. And then that's the end of this presentation. Happy to answer your questions.
Thank you, Martin, for this useful talk. Let's take a moment all to thanks Martin for this. And please, if you have any question, jump in. We have one from Adam.
Yeah, thank you. I'm not sure it was mentioned. Will the recordings be available at some place?
So the recording from yesterday is already available in the Project A family Slack, and from this one will be also at some point today.
Okay, and if someone is not part of the Project A Slack?
Well, then you get invited. Then you reach out to your others.
Okay. And maybe the one question that might be interesting for the others as well. If we have questions, do we make them on Slack or?
Yes, so there is, I think a good place is the data channel on the Project A family Slack, where also the complete Project A data team is happy to answer questions.
Okay, perfect, thank you.
We have another question from Alexei, please.
Yeah, I would like to get back shortly maybe to this constraints that you mentioned earlier. I just like while listening to your talk, also searched on the internet like how it's done, and was like wondering like if there is a reason to put constraints after inserting the data, or because like as I got it, like it mostly should be also possible to do this before. So like while you insert maybe a lot of data in your database or in a table, that will directly throw an error, if I got it right.
Yes, it's correct. Two reasons. Some databases, the insert is faster if you add the constraint later, right? So if you, for example, have a unique constraint and you insert into it, then it has, while you are insert, kind of built this B tree for the unique for the unique index, and this is it's faster to first insert and then add this index at once. Right, so there's a performance reason. The second is if the constraint is already there and you insert and it fails, then your table is empty and you cannot see the erroneous data. Right, so for example here, if you add the primary key to the customer later, then you can basically look at your customer table. You do select star from customer where customer ID is 1. And then you see which rows are duplicated and might already have a hint for why that's the case. And as I said, with foreign key constraints, sometimes the table that you are referring to does not exist yet, right? Because it's created in a different part of the ETL. So that's why it's a good idea to create foreign key constraints at the end of a pipeline.
Yeah, thanks. That's a good hint with not available the table. And maybe another more question, something different. As you were also talking about incremental topic, I was wondering about the general idea of the whole streaming pipelines. Like in this case, we were more talking about like batch processing and like remove the schema and then replace this with a new one. With the new data. How does like the streaming concept would match in this concept?
Streaming. So this is batch processing, right? So you have a schema which is a list of tables, and then you do something, and then every 30 minutes or every hour or every day you have a new version of it. And the nice thing is, if you change a column to a table, then you just do that and you deploy the new version, run it, and then after the pipeline ran, you have a schema that has the column. As soon as you do streaming transformations, then you have to deal with state, right? And you have to deal with migrations, and you have to deal with previously existing data, and this is a lot harder, right? So it's harder to change a streaming data pipeline than it is to change a batch pipeline. That's why for most of the cases, I would really challenge whether you do have a real-time or streaming use case for analytics. And if you do, then I would always say do the core metrics of your data warehouse in a batch fashion. And then for the specific real-time use case that you have, build something specifically for that, right? Because it's much, much harder to maintain business logic in a streaming transformation framework than it is in a batch style transformation. Right. So often when we talk to founders, they say, okay, we want the thing to be in real time. And then we ask whether they really have that and whether they have something where they need to react in real time on something. And it's really rarely the case. Of course, we also use streaming, right? For example, for moving data around, for capturing events from various microservices, for doing change data capture, for exchanging data between different software systems of a company. Right, so and we also recently invested in Quix, which is a real-time data processing company. Right, so but these are then more about processing events, reacting to changes in something, and not about combining data from many different sources into a dimensional model. Right, so so the answer is, if you can avoid streaming transformations, do that, and if not, then use a tool that is better suited for it. Is there more questions? All right, then thanks again for coming. It was a pleasure. As I said, we will share the slides in the Project A Family Slack. If you are not there, then reach out to you, we will invite you.
Thanks everyone for attending, and thank you very much, Martin.
Yeah.
Enjoy the rest of the day.